Today we are going to start functions. So for functions, first I want to show you two arrow diagrams. One arrow diagram is this. Here I am writing A. Here I am writing 1, 2, 3, 4. And this A is connected to 1, 2, 3, 4. Now, another diagram is here it is A, B, C, D. Here it is 1, 2, 3, 4. So here A is connected to 1, B is also connected to 1. Sorry. B is connected to 2, C is connected to 3, D is also connected to 3. Now, what is the difference between here? If you see, A is connected to many elements. So this is one many type. One many. You can compare it with your uh, fist. If you just open your fist, from the fist you are opening your hand, isn't it one many fingers? One to many fingers. So this is not a function. Why? Because every element of domain should have a unique image in codomain. This is a function. Here in the second diagram, if you check, here it is A1 is having 1, B is having 1, C is having 1, D is having 1. It is, you can say C and D both are having 3 only. So it is many one type, many to 1. So this is a function. Why? Because every element of domain has a unique image in codomain. Now, if you see, here it is A1, B2, C3, D3. So here I can say this is many one. But if I take like this, A1, B2, C3. A connected to 2, B connected to 1, C connected to 3. So this is 1 type. This is 1 type. We can write this way also 1 function. Means one element is connected to another element, one element of domain is connected to one element of the codomain. So this is 1. In the upper diagram, if you see 4 is not connected over here, but here all the elements are connected. So this is on 2 also. But here if any element doesn't have a pre-image, actually this is pre-image. So if any element in codomain doesn't have a pre-image, then it is into type. So this is, you can say, many one into. Here it is 1 and on 2. 1 is there and on 2 is there. Every element of domain is connected to every element of codomain. Then it is 1 on 2. In this case, codomain becomes equal to range. And this 1 on 2 function is called bijective. 1 is also called as injective, and onto is called as surjective. Surjective. And if both 1 and onto is there, we will say the function is bijective. So this is one many, one to many. This is many one, because here two elements are connected to one. Many one into. Why? Because into one element of codomain is not there in the range. And here, every element of domain is connected to every element of the codomain. So codomain is equal to range. So this is 1 as well as on 2. So in this exercise, we are going to do 1 and on 2. So if you check first question, r star to r star, f of x is defined as 1 by x. Is 1 and known to, where r star is the set of all non-zero. Why all non-zero? Because if x is 0, the function is not defined. Okay, so this type of question is there in exemplar also there. They have just confused you. They haven't given this condition. Okay, so you have to be careful about this. You have to check whether the function is defined or not first. Then you will check 1 and on 2. So f of x is equal to 1 by x. So is the result true? That is the second part. Let us first check the first part. If I check by arrow diagram, here this is r star, here this is r star. Means 0 is not there, all other numbers are there. So here it is 1, 2, 3, 4, 5, 6, 7. If I check the image over here of 1, 2, 3, 4, what will be this? 1, 1 by 2, 1 by 3, 1 by 4. Similarly, 1 by 5 for 5 and 1 by 6 for 6. Right? 7 is 1 by 7. Now, one more thing. What about, because this is all real number, what about 2, 3, 4, 5, 6 over here? So, can I connect it with 1 with 1, 2 with 1 by 2, 3 with 1 by 3, 4 with 1 by 4. So, isn't every element of domain and every element of codomain we can connect? So, this is 1 as well as on 2. There is not a single element in codomain which is not there in the range. Here codomain is equal to range. Check any element. So this is 1 as well as on 2. But if domain is replaced by n, means here 1 and here it is r star. 1, 2, 3, 4, so and so on. Here it is 1, 1 by 2, 1 by 3, 1 by 4, so on. So 1 is connected to 1, 2 is connected to 1 by 2, 3 is connected to 1 by 3, 4 is connected to 1 by 4. But is 1, 2, 3, 4 connected over here? Can I connect this to back here? No, because natural numbers are not 1 by 2, 1 by 3. I can't connect. There is no, there is no 1 by 2 over here, no 1 by 3 over here, no 1 by 4. These are not here. So this is 1, 1. But not onto. Why 1 1? Because every element of domain n has an image over here in codomain. 1 is 1, 1, 2 is 1 by 2, 3 is 1 by 3, 100 is 1 by 100, 1000 is 1 by 1000. But from codomain R star 2, 3, 4 or any other number does can't have the pre-image as 1 by 2, 1 by 3, 1 by 4, so and so on. So this is 1 1 but not onto. Next, if you check, next one is n to n f of x is equal to x square and f is from n to n, means natural numbers. So what can you draw for this? Sorry, here also natural numbers, here also natural numbers. So 1, 2, 3, 4, 5, so and so on. 1 square is 1, 2 square is 4, 3 square is 9, 4 square is 16, 5 square is 25. Means every element I take over here, its square will come over here, right? So this is 1 1 because this domain will decide 1 1. Now for on 2, what do you have to check for domain? All the elements of this codomain are there in the range. What is the range over here? Range is 1, 4, 9, 16, 25, so and so. But what is codomain? All natural number means 2, 3, 5, 6. Where are these gone? So range is a subset of codomain. Therefore, it is not onto. This is of into type, not onto type. Second part, Z. When I draw, because Z, domain is Z, codomain is also Z. -1 and 1. Both have image 1 over here. -2, 2. Both have image 4 over here. So is it 1, 1? No. This is many 1, na? So not 1, 1. On 2, 2, 3, 5. Does they have, do they have image, pre-image over here? No, they don't, because the pre-image will be of square root 2 type, square root 3 type, which doesn't exist. So this is not on 2 also. It is not 1, 1, not on. Let us check it for real numbers. If this is for real numbers, if I take 1, -1, 2, -2, 3, -3, they will give one image only. So not 1, 1. That is the same as previous one, not 1, 1. Now you will say, ma'am, but 2, 3 square root to exist over here, because this is also real number. This is real number. This is real number. So square root 2, square root 3 will exist over here, no, for this. But what about -1, -2? Its square root will exist over here. -1. This is not a real number, no? -2 square root. This is not a real number. So it is not onto. Clear? There are few elements whose pre-image doesn't in the codomain. So this is not onto, not 1 1, no. Let us come to next. Fourth part. This is n, this is function is x cube. So 1 cube is 1, 2 cube is 8, 3 cube is 27. So every number in the codomain will have a cube over here, no? Codomain. So this is 1 1. Domain will decide 1 1. But for on 2, 3, 4, 5, 6, 7. Its cube root will exist over here. Sorry. Cube root will exist over here. If I attach this 2 with this, will natural number will be of this type? No, na. So this is not onto. Next, Z to Z. Now can you guess? Because it will be 1 1. Why? Because minus 1 will be minus 1 over here. Minus 1 is related to minus 1. 1 is related to 1. 2 is related to 8. Minus 2 is related to minus 8. So you can say this is 1 1 type. But onto the same thing for 2 and minus 2 over here. Do the cube root will exist over here? This is integers now. But cube root will come na over here. So this will not exist. So this is not onto. This is 1 1 but not onto. There is one more method. You can just draw a graph. If you don't get how to do, how to check, you are not getting anything, just plot the graph for that. And suppose this is x square, so x square for real numbers will come like this. Now this is horizontal line cutting method. Draw horizontal line everywhere. How many times does it cut graph? 2 times. So if a horizontal line cuts a graph at 2 places, it is not 1 1. Okay. And here after 0 in y, there is no place of the graph where this horizontal line can cut. So for this is for onto. If the graph is like this, if now I'll draw a straight line, it will cut 1 1 everywhere. Graph everywhere it will cut. So this is 1 1 and onto. But this is not 1 1 and onto. Because here the line is cutting at 2 places and there is some place where there is no graph, so line can't cut that place. Right? Now question number 3, greatest integer function. What is the definition of greatest integer? That is 0, x lies between 0 to 1. 1, x lies between 1 to 2. So and so. Minus 1 when x lies between 0 and minus 1. So what do you mean by this? Means every element from 0 to 1, open interval, closed 0, closed 0, open 1. There is only 1 0 over there. Means the graph of this will be like this. So for every element of x in this, there is only y as 0. Means if you draw the arrow diagram, 0 0.1, 0 0.211, 0. Every number over here is giving you the image 0 only. So this is not 1 1. For on 2, can you, if you draw the horizontal line over here, can you cut the graph? No, na. Or you can say range is only integers, -1, -2, so and so on towards infinity, 0, 1, 2, so and so. All integers are the range of this. But codomain is, what is codomain? Real number. So integers are a part of real numbers. Na? So range is a subset of codomain. So it's not a, it's not onto. Clear? Either from definition you can say, or by graph you can say, or from code range and codomain you can say. This is neither 1 1 nor 1 1. Why? Because every element from 0 to 1 open interval, every element in this is giving you one image only, 0. So isn't it many one? And then range is only integers, but codomain is all real numbers. So this is not on. Next, mode function f of x is equal to mod x. So if I take f of -1, that is equal to f of 1, that is equal to 1. Na? F of -2, that is equal to f of 2, that is equal to 2. So is it 1 1? Two elements -1 and 1 is giving you image as 1. -2 and 2 is giving you image as 2. So is it 1 1? No, no, not 1 1. Now for on 2, if you plot the graph, the mode function is always this. Sorry. Means all positive. If you check, range is all positive integers. So range is from 0 to infinity. But what is codomain? Real, na? Range is a subset of codomain, because my codomain is -infinity to infinity. And range is 0 to infinity. So range is a subset of codomain. So this is not onto. Clear? In this, directly if you check what is range, 1, 0 and -1. So and codomain is R. So signum function is not onto. Directly you can check from this only. And for 1 1, for all x greater than 0, for all x greater than 0, this is 1, means x greater than 0. How many elements are there for R? The image will remain 1. If you plot the graph for this, what will be of this type? This is 1, this is -1, this is 0, right? Range is -1, 0, 1. Codomain is R. Therefore, range is a subset of codomain. Therefore, it is not onto. Not onto. And for 1 1, all these elements x from 0.0001, what can you think of? That from 2, whatever infinity element you can think for x, the image is always 1 of y. So is it 1 1? No, this is not 1 1. Remember, greatest integer, smallest integer, mode function, signum function. These are neither 1 1 nor 1 2. Clear? Next, if you check over here, 1 is having 4, 2 is having 5, 3 is having 6. Means all the domain elements are having one image. So this is 1 1, right? On to, does 7 has any pre-image over here? No. So this is not on to, right? Now, in question number 7, if you check, this is a linear function. Linear function you have done in class 9, 10 when you plotted the graph. What do you use to get a straight line? Also always, na? So this is always on real numbers. A linear function is always 1 1 and onto 1 1 as well as onto. How? For this I am showing you the proper method how to write. Let x1 x2 belong to R domain, and we are taking that f of x1 is equal to f of x2. Means for these two elements, f of x1 and x2, their image is same. So we will show that x1 and x2 is also same. So what can I write? 3 minus 4 x1 is equal to 3 minus 4 x2, or 3 3 cancel, minus minus cancel, you can say x1 is equal to x2 now. Therefore f is 1 1. You can plot the line also over here for this graph. Show it by the graph. The whatever the line will come, it like y is equal to 4x plus y is equal to 3. So x is equal to 3 by 4 plus y 3 by 4. Y by 3 is equal to 1, means this is 0.75 and 3. So this is 0.3 and this is 0.75. So this type of graph will come. So just check, draw horizontal line. Anywhere, draw the horizontal line over here. Anywhere, draw the horizontal line over here. You are cutting the graph once only, na? This line, straight line, is cutting by this horizontal line once only everywhere, because this horizontal line is from infinity to minus infinity. So this is 1 1 as well as onto. How will we check onto? For onto, take y is equal to 3 minus 4x. So 4x will be 3 minus y. So x will be 3 minus y by 4. Represent this function as x in terms of y. Earlier it was y in terms of x, change it into x in terms of y. Now put it in the actual function. F of x is equal to 3 minus 4x. What is x? 3 minus y by 4. So wherever this x is there, put that. So 3 minus 4 into 3 minus y by 4. This will pura put 4. So this 4 and this 4 cut. 3 minus 3 plus y. 3 and 3 cut, so this is equal to y. So this is f is onto. Either show by graph if it is 1 or 2 marks, but if it is 3 marks, then you have to show a proper this wording over it. Okay. Second part. Second part, whenever it is a square function, whenever it is a square function and on R, then 1 1 and on 2 is not sure. Remember, when on R and square function, 1 1 and on to both are, you need to be very careful. So f of x is 1 plus x square, right? So I am taking, let x1, x2 element of our domain. This is of domain. Then image is same. F of x1 is equal to f of x2. So 1 plus x1 square is equal to 1 plus x2 square. So I can say x1 square is equal to x2 square, or x1 is equal to plus minus x2. Why? Because x1, x2 is real. So both will means x1 is equal to x2 and x1 is equal to minus x2. Right? So is it 1, 1? No, this is not 1, 1. F is not 1. There are two elements now. But if it is n, domain is n, then this negative value will be rejected. Right? Now, for the onto part, y is equal to 1 plus x square, or x square is equal to y minus 1, or x is equal to positive square root y minus 1. For y is equal to 0, x is equal to minus 1. Is it true? No, x is a real number. X is real, na? So, not true. Means for 0 towards minus infinity, the x will not become real. So this is not on. Not on. Either show by this or just put it back into f of x, then show. It's your choice. Because your what is your range over here? Y, sorry, what for value of x, what value of y you can put? You can't put y is equal to 0. You have to start y from 1. Then only x will be real. Na? Otherwise, this minus 1 value will give you complex number. So this is not onto. Right? Now the main question, this 8 and 9, you can just check how to write. Same method only, 1, 1 and onto. Here, even power is there. Question number 11. Power is even. So minus 1, minus 2 will have the same image. Minus 2, minus 2 and 2 will have same image. Minus 3 and 3 will have same image. So this is not 1, 1. 1, 1 is gone now. For onto, if you take x is equal to minus 1, then minus 1, its fourth power will exist in the codomain. It's like this arrow diagram. Here minus 1, fourth power of minus 1, or minus 2, take minus 2. Will it exist over here? No, no. So this is not onto. So neither 1, 1 nor onto. Next, f of x is equal to 3x. This is a linear function. So this is 1, 1 as well as onto. Right? Now the main is, how can you check this rational function? Then this is for you. You will first take f of x1 is equal to f of x2. So x1 minus 2 upon x1 minus 3 is equal to x2 minus 2 upon x2 minus 3. Cross multiply and prove that x1 is equal to x2. That is, you have to show. And you will check this minus 3 is because if you put minus 3 over here, function is not defined. Same when you will check this one, y is equal to x minus 2 upon x minus 3, cross multiply, xy minus 3y is equal to x minus 2. What did I tell you? Make it a function x and y separate. So this will become 3y minus 2, x common, so y minus 1, that is equal to 3y minus 2. So x in terms of y is 3y minus 2 upon y minus 1. So if you check now, if I put this y1 over here, d is equal to r minus 1. So if I put y1 over here, it will then this types is not defined. That will go, na? That's why it is subtracted, right? So that's why the function is defined both ways. So x in the and this x in terms of y is actually f inverse of this given function f of x. In this way, this will give you inverse. And remember, whenever the function is 1, 1 as well as on 2, then only the inverse exists. Otherwise, inverse doesn't exist. Okay. The function should be 1, 1 as well as on 2. Means it should be bijective. Otherwise, inverse doesn't exist. And this x in terms of y will give you f inverse. This is f inverse x. That is equal to this f inverse x is equal to 3x minus 2 upon x minus. So this exercise is over. Now one question is left for the square. That is f of x. F of x is equal to 9x square plus 6x. I need to check the question. It's not right in front of me. So thank you.